Welcome to EDU World Space.
Okay, in this problem we have a prism where light comes in from the left, refracts into as it enters the prism, and then totally internally reflects on the right side of the prism. So I draw some arrows just indicating which way this ray is going. We have all these various angles. It's first angle of contact with the prism, which is 45 degrees. We have this theta 2 for the refraction of the light ray, and of course theta 3 and theta 4 for the second interaction at the right surface of the prism. And in this problem, we're asked to find a relationship, say something about the index of refraction n of the prism. So it's a pretty general problem. It's a pretty difficult problem, but we're going to try to get through it. We're going to be making use of Snell's law, which simply says that n1 sine theta 1 for the light ray in one medium is the same as n2 sine theta 2 for that same light ray on the other side of the medium. That's Snell's law. That's valid for refraction. We're going to be making heavy use of it in addition to a lot of trigonometry, as you might expect. So to start us off, let's consider that first interaction of the light ray with the left side of the prism, left interface. The light ray is initially in air before it enters the prism. So we have n air sine theta 1 equals n sine theta 2, where n is unknown. It's the n of the prism. N of air is just 1, so we're left with sine theta 1 equal n sine theta 2. And then finally, we can get this intermediate step. Sine theta 2 has to be equal to 1 over n sine theta 1. So we're going to leave that for now. Now at the second surface, we should write this at second surface, just so we're clear what we're talking about. The angle of incidence is going to be 90 degrees minus theta 2. Just need to justify that to yourself, why that's the case. And then we also add plus 90 degrees minus theta 3 plus third angle, the angle of the prism, A. These all have to add up to 180 degrees. So we're considering the big triangle. Once we have this, we can break it down a little bit. We have theta 3 theta 3 equals A minus theta 2, which is also equal to, which A is simply 60 degrees. We can plug it in now. So we have 60 degrees minus theta 2, and that's what theta 3 is. We're now going to apply Snell's law again, go and move to a second page, or rather third page. So to model the refraction at the surface of the second surface, we have n sine theta 3, which we were able to get a relation for, equaling n air sine theta 4. Okay. So doing a bit of simplification, n air is 1, as I mentioned before. So we have sine theta 4. And the maximum value of theta 4 for the internal reflection is 90 degrees. This is the maximum value of theta 4 before internal reflection takes place. For it to occur, we're going to have this following relationship then. N sine theta 3 equals n sine A minus theta 2 must be greater than or equal to 1, which leads to the fact that n sine A cosine theta 2 minus cosine A sine theta 2, all of that is greater than or equal to 1. Now we're going to go back to our results from analyzing the first surface. So I'll write that using first surface refraction, that info that we derived at the very beginning. We can try to simplify this a bit. We're going to eliminate n. So let's go to another page. We're going to need it. We're going to get this big result by eliminating n. Sine theta 1 in parentheses, sine A cosine theta 2 minus cosine A sine theta 2. All of that over sine theta 2 equals sine theta 1 in parentheses sine A over tan theta 2 minus cos A, all greater than 1. Okay, so that's a big step. We can break it down a little bit more. Going one step further, we can get 1 over tan theta 2 greater than or equal to 1 over sine theta 1 plus cosine A, all that in parentheses, over sine A. And this is equal to 1 over sine 45 degrees, because it's given, plus cosine 60 degrees. And all of that is over sine 60 degrees. So we're just plugging in our numbers at this point. And this gives us a numerical value of 2.210. So we're almost near the end. You can also break it down. You can express it as tan theta 2 less than or equal to 0.452, or theta 2 less than or equal to 24.3 degrees. Okay. Now, one more thing. We're asked to find a relationship involving n. So we're going to go back using this result. Theta 2 has to be less than or equal to 24.3 degrees. Let's finish it up. The minimum index of refraction is going to be equal to sine theta 1 over sine theta 2 max, which we found. So we can plug them in. Sine 45 degrees over sine 24.3 degrees, which we just found, equals 1.715. So the main result, which took us a pretty long time to get to, is n must be greater than or equal to 1.72 approximately. And that's it.